In this video, we have the integral of secant squared of x over the product of tangent of x and tangent of x minus 1. Now, the derivative of tangent of x is secant squared of x. And if I take the derivative of tangent of x minus 1, well, the derivative of negative 1 is 0. So I'm left with the derivative of tangent of x, which is secant squared of x. So we could probably solve this problem letting u equal tangent of x or u equal tangent of x minus 1. I'm going to let u equal the tangent of x minus 1. So it'll be a standard u substitution. Du then would equal to secant squared of x dx. So we'll transform this into an integral involving u. So again, product here, secant squared x dx is right here. That's du. This will be du here. And that's over. And of course the tangent of x minus 1, that's going to be your u. And of course for tangent of x, we simply solve right here. Add 1 to both sides, we get tangent of x is equal to u plus 1. Doesn't matter what order you have these. This is u plus 1. Or I should say the integrand is 1 over u times u plus 1. So that's a rational expression. So we can set this up for partial fractions. This would be 1 over u plus, or I should say, let's pick a constant a. So we're going to rewrite this thing, break it up using partial fractions, and then we have a b over u plus 1. So it works this way. We have 1 over u times u plus 1. So we're going to obtain the partial fraction decomposition of this expression to make the integration easier. So I'll multiply through by the LCD, u plus 1, so this will be 1 here is equal to, then this will be a, clear the fractions here, so the u cancels, I get u plus 1 here. And for the other one, the u plus 1 cancels and I get b times u. So either way you want to do this, there's different ways. I'm just going to pick out u to be negative 1 because this is actually an identity. So I'll pick any value I want to make it convenient. So pick u to be negative 1. Then what's left here? Well, on the left side, there's no u. So that's just going to say constant at 1. Negative 1 here will give me 0 here. Negative 1 here will give me a negative b. So this implies that b is negative 1. Now let's pick u to be 0 now. If u is equal to 0, that wipes out this part right here. And I've got 0 plus 1 is 1, so I've got 1a, or a equals to 1. So if I let u equal to 0, then I get a equal to 1. So that implies that I can rewrite the integrand this way. Break it up like this, for now I know the constants a and b, so I know a to be 1, so this breaks down into 1 over u, and then it's plus, b is negative 1, so this will be negative 1 over u plus 1. So that's our partial fraction decomposition. So now we just do the integration. So you can look at this as two integrals, so it's the integral of du over u. Du over u. We have a formula for that. That's the natural log of absolute u. But what is u in our case? It's tangent of x minus 1. We always have to go back to the original variable. So this is actually the natural log of absolute value of u, but u is tangent of x minus 1. And then we got here a minus, so I'll bring that down to minus. And then we got du over u plus 1. Same sort of thing. This is ln of absolute u plus 1. But what is u plus 1? Over here, add 1 to both sides, u plus 1 is equal to tangent of x. And this is plus the constant of integration. So the final answer to this then is the natural log of absolute value of tangent of x minus 1 minus the natural log of tangent of x plus the constant of integration. Thanks for watching. We'll see you next time.